Hello everyone, my name is Mojde and my PhD project is related to develop high resolution and low cost microscopy. Every one of us has seen microscope before, which helps us to see really tiny objects which aren't able to see by naked eyes. However, this nowadays microscope, have some restriction that make them hard to apply, and any defects in the hardware of this microscope affect the high resolution image in the end. So my PhD project is related to bypass this limitation and even go further. This developed microscopy is a combination of both experimental and also programming. So let's go through it. At first, illuminate the microscope and choose one sample, which is sperms. I have chosen because they are really important in this nowadays life. That's how it is. So, and magnify the image of this sample 4 times bigger, as you can see here. But unfortunately, we don't have a clear image, just blur image of these 3 samples. But we can do other things. We can change the objective and magnify the image even 10 times bigger, as you can see here. But we are just able to see one of these sperms. We have unfortunately lost one of them. So what we can do is that change the position of the sample, means that mechanical scanning, and then we can see another image of the sample. But still one of them has lost. So this objective by itself is even more expensive since it has more magnification. So what can we do? We want to have a really clear image of these 3 sperms. We want to see one of them. And also, we don't want it to be expensive. We don't want to do any mechanical scanning. So this is my project, Fourier Tychographic Microscopy. So how does it work? It just simply use one programmable LED and just one low-resolution objective lens, which has a magnification of 4. How does it work? If you look at this setup, you can illuminate this sample, which is a sperm 1 by 1, by these LEDs and capture really low resolution and blur images. And what you do, you will help by this recovery algorithm and stitch all of these low resolution image to, in the end, recover high resolution image, which is clear for all of these 3 samples. So this is the microscope that me and my colleagues have designed in USN so far, which consists of programmable LED, objective lens, and low-price camera. So the future is still open. We can even use UV LED and different design patterning of these LEDs to see even more tiny objects beyond the resolution. So if we want to see one high-resolution picture of this live, for example, cells, we need the help of improvement of efficient algorithms. The future is open. This is the future of the human. It opens great and enormous magnification, not only for scientific research, but also biology to diagnose disease. And on the other hand, it bonds computer science with physics. Thank you.